Hi students, today we'll discuss the electric field intensity due to a charged sphere. This is non-conducting. So here you can see that is your, suppose we are considering one charged sphere having radius r. So let the total charge on the sphere is equal to q, and we know in this case the charge is distributed volume wise. So volume wise means we know volume charge density. So volume charge density is equal to rho. So rho is equal to charge upon volume. So from this we can find out the total charge of this charged sphere. Then we can use the Gauss theorem to find out the electric field at the given point. So you see here, so the type of charge distribution here is volume charge distribution. So in this case, your volume charge distribution rho will be equal to q upon v, that is volume. So this will be equal to q upon 4 by 3 pi r q. So q will be equal to, by cross multiplicating 4 by 3 pi r q, this will be rho. So this is your total charge of the sphere. Now here we can find out that this will be equal to here three conditions we can take, either on the sphere or outside the sphere or inside the sphere. So we can consider any point. So in this case we will be using the Gauss theorem. So what Gauss theorem tells us? Gauss theorem tells us that the electric flux that is associated with any Gaussian surface, that is equal to 1 upon epsilon naught times the charge enclosed by the surface. The other way also there to find out the electric field, that is the flux is equal to the surface integral of electric field intensity. So we'll be using these two formulas. So first part is, suppose we are finding out any point outside the sphere. Outside the sphere. So suppose I am considering this point. So I will assume a Gaussian surface having a radius small r as shown in the figure. So for this Gaussian surface, the q that will be equal to, here we can find out by applying the Gauss theorem, this will be equal to q upon epsilon naught. Similarly, the flux will be the surface integral of electric field intensity. So in this case this will be equal to E into surface area of the Gaussian surface. So Gaussian surface is the outer surface, radius r. So this will be E into 4 pi r square. So by equating these two, we will get q upon epsilon naught equals to E into 4 pi r square. So similarly, here E will come as q upon epsilon naught. This is 4 pi r square. So we can write this one as 1 by 4 pi epsilon naught. This is q upon r square. And if we write it in vector form, then this will be equal to r unit vector. So if you see this formula, this is same as the electric field intensity at any point due to a point charge. So in this case we can assume that the total charge of the sphere is concentrated at its center. So you can modify this formula also in terms of the volume charge density by putting the value of q as 4 by 3 pi r q rho. So it will come as you can see here, this will be E is equal to 1 upon 4 pi epsilon naught Q. So for Q, you can put this value 4 by 3 pi RQ rho upon 4 pi R square. So here, this will be equal to Q is equal to 4 by 3 pi RQ rho, and Q upon here, this is only R square. This is only R square. So here, by cancelling this 4 pi, what we will be getting? We will be getting rho upon 3 epsilon naught. This will be RQ upon R square, right? So this is the derivation for the electric field intensity at any point outside the charged sphere. Now the second part is, suppose on the sphere, we want to find out on the sphere. So let this is the point. So on the sphere means here. So the same manner we can find out Gaussian surface. Here flux will be equal to, you know, Q upon epsilon naught. Similarly here flux will be equal to E into surface area. So by equating these two, we will get Q upon epsilon naught is equal to E into 4 pi R square. Similarly here E will be equal to Q upon epsilon naught 4 pi R square. So this will come as Q upon epsilon naught, that E is equal to, this will be on the denominator actually. So this will come as 1 by 4 pi epsilon naught Q upon R square. So if we modify this formula by putting the value of Q in the form of your surface charge, that is volume charge density, so this will be equal to your Q is equal to rho into V, that is the volume. So you can put here, so this you will be getting, this will be 1 by 4 pi epsilon naught, this Q is equal to 4 by 3 pi RQ rho upon R square. So this will come as, so this will be rho upon 3 epsilon naught. So you will find here E is equal to rho upon 3 epsilon naught. See this R square, this R, so this will be your R. So this is your electric field intensity. Similarly, we can also find out at any point inside the sphere.